Hey, good day, everyone. We'll continue with our discussion sa electromagnetism. So, fortunately, nahuman na kita sa sa mga preliminaries about uh, line integral, surface integral. We discuss also the Dirac delta function and also vector analysis. So, balik na kita because those are very important and needed kaayo when it comes to to have a complete understanding of this course, electromagnetism, because most of most of the concepts kaninga course is centered around the vectors, because after all, this electromagnetism course is really all about vectors and how to do about it. And we also discuss the review on differential calculus, and we also discussed the divergence theorem, how to do the curl and the cross product also. Okay? So this time around we'll be using those concepts, important concepts, para as a tool para masabtan nato ang problem in electricity, both in electricity and magnetism. So without further ado, let's continue. Okay. So I'm using this material, 2017 pa ni siya, but kina-update na ko ni siya constantly. So why is it important to study about electrostatics? Because before we can fully understand electromagnetism, because electromagnetism includes dynamics naman na siya, movement. When I say dynamic, na siya movement, na change. So in order for us to understand that, atwas ang sabton ang simple case wherein statics ang imuhang charges, say electrons or protons or any charged object. And then from that static object, we'll try to understand and analyze, is there an interaction between those charges? What are the forces involved? Can we somehow understand them? And luckily, we can understand it using the laws of physics and mathematical tools at hand. Okay. So we'll start with this one. Let's say we have a system wherein na ako'y test charge Q, big Q, and then I also have this charges around it. You have Q1, you have Q2, and then you also have Q3. So, as we know, physics is the study of forces, energy, and its interaction. So that's why we have to study this one, because sa physics, in order for us to understand the universe or anything that is around us, we have to understand unsa man ang mga ga-interplay. How does the characters of the object or the characters on stage behave or interact with one another. And one important aspect na mag-interact sila is due to forces. Unsay mga forces na nag-interplay sila. Let's say kani siya is molecules ni siya inside a glass, let's say glass, or inside a chamber. So we want to understand what are the forces that interplays or that takes place in this scenario. So for this case, for simple lang yung case siya, we'll consider nga kani siya nga system. As I've said kanina, it's static. Okay? So it's not moving. And we want to understand and to know what are the forces, sa mga forces nga nag-exist between these particles. So, in order for us to calculate ang force niya exerted by some electric charges, let's say these electric charges Q1, Q2, Q3, unsa ka ang mga forces nga nag-exert ani niya onto this object, right? Or this Q. And at the same time, kani pong Q nag-exert po siya og force towards this entities. Kani siya. Okay? So to calculate the force exerted by some electric charges, as I've said, we have Q1, Q2, and Q3. These are the source charges. Mga itong gitawag na source charge. So usa ka ang force nga gi-exert by this source charge on a test charge Q. So we know from previous knowledge nga naaring natawag nga the principle of superposition. Okay? So, pwede siya magamit. So, what is this principle of superposition? So, the principle of superposition, it states that the interaction between any two charges is completely unaffected by the presence of other charges. So, it really simplifies the problem at hand. Okay? So, let's say we want to calculate unsa ka ang overall force. Unsa ka ang overall force aning kaninga system. So, it's like i-separate siya ba superposition of principle of superposition. Ang interaction daw niya between two charges is independent or unaffected by the presence of the other. It's like wala siya. So pwede ta mag-ingon nga saka ang force nga nga naaani plus saka ang force nga naaani. What could be the force of interaction between these one? So, tulo ka buok. It's like, nag-calculate ka sa force, separately, independently. And then you take the sum to get the overall force of the system. So, that's how the principle of superposition works. Okay? So, as I've said kanina, the force exerted on Q by Q1, Q2, and Q3 is therefore equal to the vector sum. Okay, vector sum. So we can have F1. Let's say F1 is the force exerted. So ano siya? Force exerted by siya? Let's say ang force F1 is padulong din ha. Meaning, iyang itulod. So it's like nag-repel siya, right? So this is F1. As you can see here, F1 is the force exerted by Q1 on this test charge Q. Then we have the force F2. So, F2 here. Okay? So, F2 is paduol siya. Okay? So, paan ang ihang bira. So, pabira siya. Pull. So, it could be, this is positive and this is negative and this is positive. It's like that. So, this is F2 now. And then, the F3, this one. So, iha pong birahon dito. So, makating din ka, unsa ka ang net force no asa ka jud padulong ni siya overall na ay force nga nagabira diha na ay force nga nagbira dinhi tapos na apoy force nga nagbira adto. Okay? So you take the sum of those individual forces acted upon this test charge Q by the presence of these source charges, right? Source charges, you can get the overall force. Okay, you know what I'm talking about, right? Ang nakuha ninyo kung asa ko padulong. So, in principle, in concept, this is what happens, right? So, we physicists, we are curious enough to know unsa ka ang iyang quantity o specific niya nga value ba? Unsa ka ang specific value of force? Unsa ka na siya? Unsa iyang magnitude? And unsa ka iyang direction? What is the net force? So overall asa ka this siya? Usa kay force niya nga net, right? After all these forces nga kay tulog if imo siyang gi-incorporate na. And what could be the direction? Asa ka dapit diri ba ka nga side or diri nga side? Right? So the total force exerted by the source charges on the test charge is equal to this one. Okay. So, muna itong gimension na kanina, this is the total force. So, this is the total force. That's the total force. Where we have F1, so this is force acted by Q1 onto Q. Force acted by Q1 on Q. F2 is force acted by Q2 on PQ and so on. So there could be many, as many source charges as you want, not only limited to 3. Okay. So the force is actually given by this one. This is coulombs. If makarecall mo sa inyong coulomb, di ba? Anak man ang coulomb. You have K, Q1, Q2 over R squared, right? Mao na siya ang in high school mo gina siya. Where K is given by 1 over 4 pi epsilon naught. So we have, kasi kung pareha silang charge, kung ng Q square siya. But if not, so we have Q1 for Q, Q2 is big Q, and then R squared. Okay. So we have this one. So this is the, muna siya ang katong sa test source na Q1. So you have Q1, Q, and then you have R1 squared, the distance between them. Okay. So for our case, we'll be using not R1 but actually kato bitang ana siya. Right? Because maama na siya ang katong R prime minus R. Para dili ta malibog ba? Where R prime is the, it's like this. So this is the origin. And then this is Q. And then this is big Q. So it's like this. This is, kana siya nga vector. That's your R prime. And kana siya nga vector. That's your R. And the distance between them, kani siya, nga color. The distance between them, which is this, the distance between them, kana siya. That's what we call kana, which is the difference, ana niya. Okay? So, ano siya? So, that can be replaced by this one. Ang R ni mo, instead na R1, ay mo na siyang R1. Okay? R1 square. Okay, mas general mo ko siya. Okay, this is more general because kani okay na ni siya. Okay na ng R1 if ang imuhang kani siya is na siya sa origin. Right? But if not, so pwede mo siya anywhere. So mas general ni siya. Okay, just take note of the difference between the source charge and the test charge kani distance. Okay? And then we take the sum. I-sum na siya. Common niya kay Q, di ba? Q na ay Q din na ay Q din na ay Q. So, muna siya nigawas ang Q. And then ako Q1, Q2, Q2. So, it must be a sum. Yeah, sum siya. That's why na ako ani. Right? You have Qi over Ri square. The direction R hat I, where I runs from 1 up to N. N is the total, pila ka book ang total liha nga charges. Could be 20, 100, or an arbitrary number. So we can calculate for the electric field generated by the source charge. So what's my electric field? We know from your previous concept on electricity, force is actually given by Q times E. Okay? If na ko electron or source charge Q, with the presence of the electric field, it can cause motion, right? And that's tantamount to a force. So that's why na ako a force. So to get the electric field, we just simply mura mo na siya ibalhin diya. So we have F over Q. Okay? And take note, this is a vector quantity, the electric field. Force is also a vector quantity. So we have this. Okay? So mura man i-divide. So to get the electric field, so this is F, right? If you will divide that whole thing by Q, this cancels out. That's why we have this equation now for the electric field. Okay? So simply saying, we can calculate for the electric field produced by source charge. Could be electric field produced by 3 charges, depending kung kaning any mo, mamana siya ang total. It could be 3, it could be 4, it could be 5, and so on. Right? So, however, kani siya, ato nang i-assume nga na ako'y mga charges diha. Let's say, diha, discrete siya. So, nako'y Q1, nako'y Q2, nako'y Q3, and so on. Right? But in most applications, the source charges are not discrete, but are distributed continuously over some region. Okay? The following 3 distributions will be used in this course. So, instead na discrete na siya, in reality, wala, di ba kakita og let's say, system nga na 4 ka electron nagtapok, right? Na 5 ka electron, 5 ka charges. Distributed siya over a solid. Continuous siya. Could be a rock, could be a cloud of electrons. So, dili siya discrete. It's actually continuous. It could be distributed over a line, could be distributed over a volume or a surface. So, that's why we have 3 cases here. We have a line charge. Let's say, ang imuhang electron, imong charge is distributed over a stick, okay, or a rod. And we have a surface charge. It could be kanang thin sheet of, let's say, thin sheet of anything. Tapos, that's something, that thin sheet of, it could be anything, na siya charge niya. So, overall charge. And then, define ang ihang charge per unit area given by this sigma. Could be volume ang ihang distribution, could be a sphere, could be a cylinder, could be anything. Basta kay volume siya, and it's defined by the charge unit volume rho. Okay. Now we are interested in calculating the electric field, let's say at some point P, okay, by this charge distribution. Let's say na ako'y let's say this is my charge distribution, or this is my source charge. Okay, tapos I want to calculate the electric field at point P. Okay, so this is point P. Because this is a source charge, it will create an electric field around it, right? Nana siya electric field. So in that case, muna electric field. And I want to calculate what is the strength of the electric field at this point. Okay? What is the strength of the electric field? What is the magnitude? And what is the direction? Okay, that's all I want to know as a physicist. Now we can actually do that. Okay? So, from our previous knowledge, ako sa i-post kisaba kay ang mga dogs. Okay, let's continue. So, from our previous knowledge, di ba, ito mo na ibawaan nga, in calculating the electric field at point P is given by this. So, we have summation I runs from 1 up to n. And we have Qi over Ri squared, Ri hat. Okay? So, this is not true anymore if ang imong source charge kay parehaan, di ba? It's like this. It's not discrete anymore, but it's a continuous charge distribution. Okay? That's why it says here, replace the summation over the discrete charges with an integration, OMG, okay, over the continuous charge distribution. So instead na sum, we know the drill, right? Okay. So ang kanisiya, it becomes an integral, okay, and this one becomes like that, dq. So small change, right? So ang q mahimong dq, and then your integral discrete man siya from 1 up to so we have the integral of dq, the sum ramang ihapon siya, but this time around it's continuous na. So for a line charge, we have this. Again, to para mag-consistent sa to ang notation, sorry for this, r, that should be r squared, okay? And then this one, that should be r R hat. Kana siya nga R. Where R signifies the difference between the source charge and the field at the source point and then the field point. Kana siya. So take note of the change sa imong equation sa electric field. Di ba kanina naman to? E equals 1 over 4 pi epsilon naught Q I over Ri squared Ri hat. So kana siya becomes the integral here, the line, and then the lambda, the Q becomes lambda dl. Okay, where lambda is the line per unit charge, per unit length, I mean. Okay, for the surface nanigihapon siya, so this is actually dq sigma dA for the surface. So kanina case, dq here is lambda dl. Okay. Then we have the volume, 1 over 4 pi epsilon naught integrated over the volume given by this. So technically, ana lagi na siya. Basically, ana. You have 1 over 4 pi epsilon naught dq over r squared, right? Where dq, it could be anything. Ang dq pwede siya line, where line dq is lambda dl. That's why naana siya din ha, right? Or pwede put ang dq, it's a surface. You have sigma dA. Then your dq could be volume element, so that's rho d tau. And gika na siya sa ato ang discrete, right? We have qi over r squared, r hat, 1 over 4 pi epsilon naught. Kana siya. So from here, nahimo siyang this integral from discrete to a continuous source charge distribution. So we can now calculate for the electric field caused by this charge distribution at this distance. Could be at point P. So nasa R diha, which is the distance between the source and the field point in question. So later on we'll be having examples para mas masabtan niya ang concept. Okay? So here, again, we will replace that with this one. By the way, nag-upload man ko ani og files na PDF na form sa ato ang lesson. You will see there nga ang ato ang notation nga gamit is kani. Kana. That is a unit vector from a segment of a charge distribution to the point P. So let's say for line charge, it's like this. Nakoy line din ha. And then I want to calculate the electric field at this point P. So nakoy segment. So this is my segment. That's my lambda dl. And I want to calculate that one. Saka ang yung electric field from this point lambda dl up to point P, the field point, and this distance is given by this. Okay, kana siya. Or if surface siya, so surface, pwede inana ang surface nako. So nako is small increment diha. That's what we call the sigma dA. And then I want to calculate the electric field felt at point P due to this charge distribution. Okay? So this is now sigma dA, and distance niya is given by that. Okay? Or it could be a volume charge distribution. So now say ball or a spherical ball or spherical ball. Tapos na ako volume element diha. Okay? And then this is what we call my rho d tau. And I want to calculate the electric field at point P because due to this charge distribution, and the distance here is given by this. So mo na siya ang pasabot ani nga equation, these three equations here. So we have for line charge distribution, and this is for the surface, and for the volume charge distribution. Okay. So example. So let's say we want to find the electric field a distance z above the midpoint of two equal charges q. So na siya di q. A distance d apart. So this is d. Therefore, automatically this is d over 2. Tama. Now you check your result if consistent with what would you expect. Say kung z, unsa kayo result dapat if your z, this one, the z is much greater than d. So kung meaning layo kay na siya, you would expect na unsa kayo result niya. And then for letter B, this one, we repeat the same procedure, but this time make the right hand charge negative q. So this is negative q na dayon. Whereas on the left, this is q. So this is q, and then this is q. Okay. So we are already given with, actually, gihatag na nidaan ang kaning, tagaan na tamudaan o kaning ihang visualization. Pero in reality, if given a problem, kanilang gina siya problem ang gihatag. Wala ni siyang visualization. Okay. So for this case, para masayad na itong calculation, it's already given ihang visualization. Meaning, kung siya pasabot ani, we want to calculate the electric field at distance z. Tara. Distance z. Okay? Above the midpoint. This one. Above the midpoint. Sakay. This is P. So, saka yung electric field. So, naman siya sa center. So, symmetric siya. This is very easy or easier to solve siya. Because, if you notice, this is the electric field sa right na part. Okay, gano siya. And this is the electric field sa left. Take note, mag-cancel na ang ihang x component, right? Take note, kanin siya pa-left, padulong sa wala. Ang kaning sa left part ng electric field, padulong po siya sa right, di ba? So, mahitabo is, of course, ang kanin siya mag-cancel. Opposite man na siya. What will remain is the z component. The z component of kanisiya, the z component ana, and the z component of this. So it becomes actually times 2 siya. So to get the electric field, we have electric field as actually 2 times the z component. Okay, z component. Z hat. Direction niya is sa taas. Okay, so muna ang iyang electric field. So how do we calculate for the electric field then? Let's open up ano lang sa yan eh. Di ba kanina is sorry. Okay. So we are given with this problem. We have Q, and then sa midpoint niya, I want to calculate saka yung electric field niya. Right? So this is d over 2. This is d over 2. And then this is distance z. Okay. And then we have this. Kada siya. Oh, sorry for my drawing. Kada siya. Okay. So kada siya. Ana siya ba? Right? Sorry for my drawing. This is E. Gikan siya sa right. Yan siya gikan sa left. Okay? And then, we know nga mag-cancel man ang iyang electric field sa X component. We are left with so ang X component cancels. So we are left with the Z component. That's why our electric field at point P is actually given by twice kay duha man ni kabo component sa L o sa R. Right? Or we can simply say EL plus E right. So Z component. Or we can just simply say 2 EZ. Okay? Pareha naman na sila og electric field dahil lang og direction. Okay? So, muna siya mahitabo. We have 2 actually E tapos the Z component, if you take a look at this, let's say this is your theta. Okay, sorry. Okay, this is your theta. So the Z component is actually it's actually the Z component, or pwede ka matanaw din ha. The Z component is actually kani siya nga component, which is cosine, right? Cosine. This is cosine theta. So we have E cosine theta Z hat. So mahitabo, we will have 2 E and cosine. What is cosine theta? Cosine theta is just this, Z over kani siya nga distance. Kani. Ito na siya. Right? Z hat. So we write E, which is 1 over 4 pi epsilon naught Q over R square, right? Now what is R? What is R then? So, pwede man ito makuha din eh. Right? Pythagorean theorem. So we have, that's actually the square root of t over 2 square plus c square. Right? Okay, I hope again it's clear ha ang kanisiya. This one is because kanisiya Pythagorean theorem. Okay, this one and this one Z. So if we substitute it here, kanisiya, can I change? I'm gonna change in color. So if we substitute this one in ha, kanisiya. So this is actually d squared over 4 plus z squared to the 1 half. So if we substitute that one, that becomes okay. It becomes 2 over 4 pi epsilon naught Q Z over d squared over 4 plus z squared to the 3 half C half. So that is now my electric field, okay, at point P, because of these two charges which are both of magnitude Q and separated by a distance d apart. Okay, so this is now my calculated electric field. So I hope this is clear. Okay, so natin question ganina nga, what if sa kahay itong i-check ba nga when z is much greater than d, what will happen to this equation? Okay, so if that will happen, if z is much greater than d, okay, kani siya is dako kaayo, so this one is very negligible. So sa kaninga term kaunon actually ang z sa D. Kaunon sa Z ang D kaninga term because gamay man siya compared to this. So your equation becomes this 1 over 4 pi epsilon naught 2q z over, so we are left with just z square. So z square to the 3 half, right? Or mag-cancel man, di ba? So this becomes 1 over 4 pi epsilon naught 2qz over, ang denominator, the z square to the 3 half becomes z cube. Or it's just z hat na siya. 1 over 4 pi epsilon naught 2q over z square z hat. Okay? So, what can you conclude based sa kani when z is much greater than d? That is actually the Coulomb field, or the electric field generated by a point charged with charge 2q. It's as if ang imuhang charge kay isa ra ka buo if this is way greater. Okay? It's like instead na ang makita nimo is duha ka book separate, if this one is layo na kay siya, from that perspective, layo na kaayo ang z, it's like ang duha mahimong usa. So it's like one point ay makita, but of course ang charge niya is the combination of the two. So 2q. Because mo man ang result nimo, right? So it's like this. Limit niya ba? So this is now the field by a point charge of 2q. Okay. Now how about the second example? So let's look at the second example. The same gihapon siya, but this time around the right charge is replaced by a negative q. So is manong ani man siya. Okay? Ang iyang itsura is ani siya because ang negative nga charge is ang pasulod man ang iyang electric field, right? Ang positive is pagawas. Okay? So lahi na siya. Instead na z ang mag-cancel out, like tapos sa part A, sa B is na mag-cancel out is ang z mismo. Right? So mag-cancel ang z, you are left with the x component. So x component na po na mabilin. Okay? So let's go back here. So it's like this. So negative q naman siya. This is positive q. So padulong na diha iyang na. So we have E, L, and then this is ER. So the Z component cancels. So mahita po isang electric field becomes 2EX. Right? So X component na siya. So rewriting this one, we have 2E. Okay. 2E. So ang X component, this is theta. So cosine gihapon, right? So cosine theta x hat. So you have 2q over 4 pi epsilon naught. The cosine here is kani siya nga part. So that's actually, oh, napa na siya distance r, right? Over 1 over r. So this is, the cosine part is d over 2 over r. Again, r is the square root of d squared over 4 plus z squared. Right? So this is square. Okay. So 2q over 4 pi epsilon ha. So d over 2 mag-cancel naman ang 2 din ha. So becomes cancel na siya. This is qd. And then we have 1 over d squared over 4 plus z squared to the 3 half x hat. Okay, so that is now my electric field. If you change the charge sa right hand side, okay, so this is my electric field. So it's actually quite easy if you are just doing. So later on, napay mga techniques nga mas masayon pa rin siya because this one is, it involves mga good vectors. But for as long as di na ta malibog sa iyang direction, unsa ang iyang mga component kay mag-cancel and what is not, then that it would be easy and makakuha ra ka dapat sa imong dapat isolve. Okay? Let's continue. How about this one? You find the electric field at distance z above the center of a circular loop. So, na ako circular loop. Circular loop diha. Tapos, sa center niya, a distance, this is point P, so this is z na distance. What is the electric field? And then, the circular loop of radius r, na siya uniform line charge kay line man siya, pa circular lang, sa circular ring. So, for each segment na siya lambda. Okay? Wherein, ang total charge Q niya, total charge is just lambda L. Why is this so? Because lambda is charge per length. And if you multiply the length of this ring, which is 2 pi r man, diba? You get the total charge Q. So, naman na siya ang drawing niya. This is similar to the previous example, katong duha ka point, right? Circular ring na niya. So, anywhere ka mag-point diha, sa dinhi nga part, kang electric field, dilipot nga part na siya electric field. Take note nga mag-cancel ang iyang what? X component. Ang mabili na gid per me is mag-cancel ang X and Y component. Ang mabili na lang is ang Z component na. So that simplifies the problem very much. So this is the solution. So we have DE. So this is the equation, right? So that's actually given from E, mo man ang electric field, di ba? dq over R, where dq is given by this one. This is dq. And then your R is kani siya nga distance. Oh, this is R squared. Okay? Ang R nimo is tara, balik ta. Okay, muni ang R. Right? So that's R, this is Z. So therefore, this is the square root of R squared plus Z squared, or R squared is just R squared plus Z squared. Hence, mo is here. Okay. So horizontal components cancel, leaving us with the vertical component only. So na ako D is Z component lang. Okay. So I have now DE, and this is now this is the Z component. Right? It's gonna say Z component niya. So this is your theta. It's actually cosine, right? Cosine theta, ang Z component. Cosine theta is just Z over R. Okay? Remember that. Cosine theta is Z over R. That's why we have this Z over R. This is R. Tama? So we have your DE is just this one. Substitute lang. So this is, can you see times this one? Okay, naisayop din eh. This should be square root. Okay? Square root na siya. Okay, it's just R naman. R is just this one, square root. Okay? So, na siya square root din ha. Ako i-erase ha. Erase. So, there should be a square root here. That's why na ako 3 half. Because kani siya is mama na. Times kani, you have 3 half. So, the total electric field generated by the ring can be obtained by integrating DEZ. So, integrate na to over this one. Where DL is just, we know unsa man ang kuan, di ba? Iyang this is just like finding the circumference of that ring, where the circumference is given by 2 pi r. Right? Or nag-integrate ka sa DL, it's like nag-integrate ka from 0 to 2 pi. Okay? With r is just constant. So we have 2 pi r. So from this one, ako 2 pi r. Okay? That's why we have, after integrating, we have this one equation here. Then we are just left with this equation. Now the direction in here is, there should be z hat, because that's a vector quantity. Okay, that's a vector quantity. Okay, that's it. That's how you solve for the electric field using our method. This is gikan man to sa pagkuha na to sa force, isa na discrete, then for na special case na discrete, but mga bulag-bulag ng mga points ba na say source charges. But most of the time we're not dealing with discrete source distribution, but continuous. Like for this case, it's a ring kana. Yung charge is na distributed along this ring na. Okay? So another example here, this is quite challenging example. You can do this at home. You can practice. So you try to solve this one. Solve this. Nanadiri ang given niya nga scenario kung saan siya pag-analyze. So you just have to find the electric field a distance z from the center of a spherical surface. So spherical siya nga surface, like empty or hollow siya nga kuan mga ball or spherical shell. Okay? So I think that's it for now for calculating the electric field of a point charge, series of point charges, of a line charge, surface charges, and the volume charges. Next week we'll be discussing, or for next lecture we'll be discussing, continuing our discussion on this. We'll be applying we will be applying the things that we learned in the previous chapter about divergence, curl, and also divergence theorem. We'll apply that to electric field now, or electrostatic field. So that's it. Goodbye. Stay safe, thank you, and stay healthy always. Cheers.